All right, welcome. We are looking at Acroscape architectural and infrastructural concepts. Is my company idea for architectural ideas, new innovative concepts for that. First, we're going to check out the notes on the laptop, going to move on to notes in the binder, and then finally going to finish up with notes on the phone. And then notes on the phone, just going to kind of take a couple minutes at the end, probably to copy, paste, transfer them over. There's not that much this time. I'm just kind of prefacing it maybe for future videos. If I take a little bit longer, it's probably going to save that for the end, get through all the information that's written here, and then do my own little typing at the end there. So kind of give myself and others a little time to process and think about everything I've said. Now, diving right into it, Acroscape architecture. Notes on the laptop here. We have a half pipe highway. And it's kind of a little more difficult to turn my laptop around, but essentially it's like regular highway, except this side, so it goes like that, and it's kind of rounded like that, kind of like a half pipe, and you got the sidewalks up here, and then the street down here. So if a car wants to hop over the road, it really has to try. So kind of a safety feature plus to kind of just keep things in their lane. And so like it would essentially be curved up like that, maybe not after every lane, but on the very edges of the highway. So there's a rail on the side as a guardrail on the side by the sidewalks. We have the half pipe road down in the middle, sidewalk up top, and the walls and street. Okay. So the half pipe highway, what is it? Main roads and highways dug into the ground resemble half pipes or possibly fully enclosed tubes or pipes. They're predominantly for 3 to 4 lane roads and highways. Each half pipe or tube only allows traffic to flow in one direction. Why? Aesthetically appealing, looks cleaner and more organized. I guess depends on who you're asking, I guess. Convenience, little to no yielding or stopping, no intersections, no stop signs, and no stoplights. Safer roads and highways, less needless accidents, injuries, and deaths. No intersections or merging lanes. This results in significantly reduced chances of collisions. Traffic only flows in one direction in all adjacent lanes within the same pipe or tube. Steps to take. Propose the idea to a governmental entity or go through the proper channels in order to receive authorization and permits to construct this type of project. Team up with construction company or companies and other necessary business entities in order to obtain the workers, tools, and equipment required to construct this project. Notes. Most public roads and highways are equipped with a variety of features in order to make them safer, such as stop signs, stoplights, painted lines, etc. However, roads are not as safe as they possibly could be or should be. There are ways that proper safety precautions can be effectively implemented and danger can be avoided, thus saving countless lives and preventing countless injuries in the future. Obvious obstacles that make the issue of road safety more difficult to resolve are time frame of construction and obtaining proper permits, cost of construction and other variables, commuter convenience, environmental impact, and modern engineering capabilities to construct a structure such as this. All right, we have soundproof rooms, custom soundproof rooms. Research how to build one, then come up with a variety of schematics for different ideas for custom soundproof rooms and soundproofing technology and techniques. Products, classic and traditional, we got none here. Products, modern and contemporary, got none here. Yeah, I need to transfer more information over. I know I got some. Prospective partnerships. So far, I got A-Line Architectural Agency, Allen and Phillip Architects. None of these are new ideas, so just press on past this. And then research questions. I'm gonna try to only plug in like my own personal novel information, like where it's my own ideas. I'm not gonna basically take what is other stuff. Like I have prospective partnerships. I could list out all these companies. I'm like, it's not really like my own new ideas. So I'm just kind of skipping past that. So back to questions. So research, I'm going to skip past the vocabulary because again, not something I have knowledge of completely yet. Not my own personal information or it's not a new idea for me. So The questions are at least like my thought process. So, considering how new technologies and methods are constantly being designed, developed, and introduced, how do you plan to adapt novel environments, people, and innovations in situations? Question two, how does cement produce carbon dioxide? Question three, would it be possible to create a machine that replicates the process of evolution by mimicking the carbon eliminating or reducing ability of plants? Could plants die from too much carbon dioxide? How high were carbon dioxide and methane levels on Earth when it was first being formed during its primordial stage? When new technologies are introduced or old technologies are abandoned, how do engineers adapt their equations, formulas, and methods of approach and to design and development formulas and methods of approach to design and development in new environments or situations? What is the metallic microlattice, the world's lightest metal, developed by HRL Labs? Tell me about its light and springy qualities. I have in welding, what is peening? Sticker labels, how do I make custom warning stickers? Use this knowledge to create custom stickers for businesses, logos, and other designs for marketing. Theoretically, if one were to attempt to pull something, in other words, the moon, towards Earth using a series of cables, how much cable would be required? What would the cable need to be made out of? Would the cable or cables need to be strategically placed in specific locations on Earth and the moon? How much tension would this cause the cables? How much would happen during and after I guess it would depend on what the cables are made out of. What would happen during and after the collision of the Earth and the moon? Would the rate at which the two objects were reeled in closer to one another have any effect on the final speed of both objects prior to impact or severity of the destruction following the collision? It's a different question. Okay. All right. So those are Acroscape construction notes on the laptop. One's on the binder. Acroscape architectural and infrastructural concepts. It's an architecture and infrastructure design firm. Hashtags, we have architecture, infrastructure, concept art, blueprints, schematics, prototypes, civil engineering, engineering, and terraformation. All right, we have this idea here. It's like for a little city or town or some building, maybe. So basically, how this one works is imagine digging out steps like that. So you have a ring like this. So you have a ring, and then now fold it flat. So this is land. So you have a big ring shape like that, and then each step goes down like that. So each sequential level. So like stairs, like stairs. There we go. Now I'm doing it right. There we go. And then in between each level, so like on the stair edge, or maybe the stair would be longer. So like I call them stairs, but they're basically long platforms. So you have long flat space that goes lower, long flat space. But like say you got this lower, this long flat space, building's gonna be in the middle of that long flat space. And so that goes over and then down. You have a ledge kind of looking over to the other side. And so basically you're gonna start off here. You're gonna have flat land, a little bit of a ledge, kind of a rail so people can look over, right? That's gonna drop down. That's going to drop down, and then it's going to go this way. You're going to have the building in the middle here, little park or kind of grassy area or something else, walk area, and then over here, same thing on that side. And then you're going to have another rail, and then same thing goes down again. I'm trying to see. And then on the insides, so like basically for every step, so over here, on this wall, you basically have buildings and structures and kind of stores, shops, whatever, rooms inside that. And then you got this step goes down where you have over here, the ledge. This goes down, and inside of here, caved out and built into here, we have other rooms and stuff. So you got gaps between the buildings contain gardens, fields, rivers, roads, etc. Above ground, each progressive building that gets closer to the center ascends higher than the adjacent building that is closer to the outside. So basically, the steps are going like that, but the buildings built on the steps, those progressively get taller with every sequential step. So the steps are going down, But on every step, each subsequent building from the outside in gets taller and taller and taller and taller and taller until we get to the middle, and it's the tallest one. But the middle tallest building is also on the middle lowest step, whereas the outermost shortest building is on the outermost least deep step. I hope I'm explaining that right. I'm trying here. All right. Above ground, each progressive building close to the center ascends higher than adjacent building that is closer to the outside. Below ground, starting from the outside, going inward toward the center, each building descends deeper into the crust. Yeah, so they also have more basement levels too. All right. Next up, we have the Acroscape or Helios Interstellar Aircraft Carrier Submarine. The iceberg, aka the iceberg. So basically it looks like this. So the water's on top. So water is over here. The only thing poking out of the water is this little piece right here. So the water's up here, see it. And then the structure over here where it houses all the aircraft and stuff, where it launches it up through it and out. But that's all underwater. All right. There's a hatch that opens to reveal the hangar and closes to conceal and protect the hangar. There is okay, so the entire structure, so that's on top, and then all underwater is the electromagnetic slingshot rails, so kind of like a rail gun, but for airplanes. So that'll launch them up, and for drones too. Like this will have such high acceleration that will be experiencing such high G forces that it is very unlikely that it'll be practical to put a human in there. I think this will be mostly for drones. So we basically just slingshot them out. Like basically go all the way around too. So you have rails going all around the cylindrical thing. And I have it drawn out here where it's, I think, an X-ray version of it where it's not on the outside, but on the inside, or we could have ones that are on the inside and others on the outside that are maybe actual sea vessels or sea-worthy vessels that kind of go out. And then the ones inside are the ones that can get launched up into the sky. So maybe, yeah, the ones, we have a big column, like imagine a hollow row. The ones inside of it are the ones getting launched up through the hatch out into the atmosphere. And then the ones outside of it, which are still underwater, are the ones just kind of detaching and going swimming through the water. All right, so electromagnetic slingshot rails, kind of like a rail gun. Use railgun technology to launch drone aircraft. Oh, all right. If I would have kept on reading, I have a little note here right next to it. Already got that covered. Cool. All right, and then underneath of that is where you kind of have it tapered off. And on top, looks like we have the mess hall, and these could probably change, but we have the mess hall here on the first uppermost level, then bunks, we have a control room or op center, we have a few other things, and the engine or reactor, and a few other things that aren't labeled yet. All right, and then for the craft, the aircraft or sea craft, looks like almost like those little Enjoy pods, but like right there, kind of like a teardrop shape with the thruster kind of flattened out or way in the back. So the wing can extend. Okay, so it's like a pod that way, and then the wing extends that way. So it's flying this way, and the wings extend that way. And then they have scramjet vents. So scramjet vents, the wings open that way. And so it presses back the wings, and plus the wings have like a little vent inside of them, so it helps with the air intake. And we can use that oxygen for the scramjet vents or scramjet engines. The wing extends, folds out that way. And there's airflow. Airflow intersects, creating an explosion used to propel the craft. So basically it goes that way. Air basically intersects at just the right point where maybe there's like a little hollow areas or porous areas where it can kind of like a bigger where something like a scoop kind of catches it and brings it back here, creates a little explosion or something by maybe having an extra little chemical catalyst fed into here where the extra oxygen is vented and high pressure and is forced into this one concentrated area, which can then be taken and reignited and could possibly need another catalyst. uh, to create that mini explosion, and then also a protective shielding to maybe prevent the aircraft from getting damaged from those extra thrusts. I don't know. We'll see. I don't know if that's how air would work anyway. So, because it would go like that, and then you'd have the turbulent flow, and it wouldn't necessarily come pushing back this way. And even if you had something else behind it or something like that, that would create drag. Um, all right, the train of airflow reseparates, then converges again, generating an air pocket that further accelerates the aircraft. Yeah, the aircraft is moving this way, and when the air rejoins, it's doing turbulent flow. It's not going to come back and propel it this way or something. I don't know. This one's I don't know. I don't know. I'll have to look up the physics of and like the aerodynamics there and see how that would actually work in a like say one of those like wind tunnels or something like that. See how it actually work in a real simulation. All right, for this next one, we have walls, like aquarium walls. Like, so basically all the walls, we have the structural support beams. So we have the load bearing walls. Those are pretty much left alone. But the rest of the walls are kind of like where the windows would be. Those are hollowed out. And so instead of having just one window, we have a little bit thicker of a wall. And then we have aquarium looking deals in every single wall. And so one wall, so wall one would be like a mountain, like a mountainous biome, and these are like miniaturized replicas of different places. So we have like a miniaturized mountain biome with like desert or dirt, and then we have mountains with maybe like some snow caps, and then a little thunderstorm over here with lightning. And then there's little like electromagnetically charged nodes over here, so that way they can kind of like the Tesla balls. You touch those and they have a little zzz. So we have something like that where it's like real low voltage and basically be able to um, kind of do like some lightning or something like that in a little aquarium. So I have the cloud kind of more static and just kind of placed there, and then the ground, and then little nodes right here, and then you kind of like activate the electricity periodically, and they'll do like a little to kind of simulate lightning strikes. The on wall two, we have a water biome. So this one's like a beach. So we have the beach, and then we can have like little fish or something. We can even put fish in there, like real fish, and feed them. So we can have actual creatures in there. And then on the maybe on the mountain biome, we could have like little lizards, like little creatures or something. So looks more lively. On wall three, the city or flatland biome. This one just has like a city built onto it where you see buildings. And then wall number four is like a forest or jungle or swamp kind of biome. And so it's kind of like a miniature replica, like a forest biome or a jungle or a swamp. Maybe worms or snakes or frogs, even like little frogs would be kind of fun to have in that one. All right. All right. So here, I don't know. Here, let me show you this actually. I'll show you that. So that's what the walls look like there, sort of. Still need to get better at AutoCAD. Uh, and then this one is specifically for the Thunderhead. So it's kind of the design for that. So, all right, the Thunderhead. We have the plasma or the lightning. So we have connecting from the Thunderhead to a node down here. So the lightning electricity is forming an arc between one node up top and then the node at the bottom. So bottom view of the Thunderhead, you kind of see the clouds like that, and then different nodes spread all around. But this one particular is being activated. Whereas looking down on the land, there's a bunch of nodes down here with one down here being activated. So it's kind of random, like one up here will be activated, one down here will be activated, and next strike, like one over here will be activated, and one over here will be activated. So it'd be kind of randomized, or it could be like a formula used to make it seem random. Electrically conducting nodes activate and deactivate to simulate lightning strikes. And then on the side of the glass, we have like a little waterfall dispenser, and there's a water pump that leads water. So you have imagine this is the side of it. You have the border, so the window glass on one side, then you have the border on one side. There's water containers. So there's a water collection container on the bottom, and there's a pump on the side that goes through the side of the frame, and then gets pumped through another rail over here. So pumped through another pipe up here that redistributes the water up above. So there's a waterfall dispenser. Water trickles down, making it look like rain. And then there's a water basin or collector, which feeds back into the water pump, which pumps the water back to the waterfall dispenser. So water trickles down the glass, offering privacy while providing fun and aesthetic features to enjoy. So yeah, the water pressure can be increased or decreased to simulate like lighter, heavier rain. There can even be mist for fog effects and stuff like that too. Like use dry ice for like, say, if you have like a biome that's supposed to resemble the San Diego coast, and it's like early in the morning, you have like the fog rolling in, and like, I don't know, it's kind of cool. Then we could have like different lighting and stuff like that to resemble sunsets and sunrise and all that. Aura City. This is kind of originating from a prototype generation. This was something I thought about back in high school. It's like a group that I wanted to do. Prototype generation. It's Aura City. So Prototype Generation Tower, that was the company. It's not really the name of the city. So Aura City has Prototype Generation Tower in the middle of it. And then it's kind of like the opposite of the other idea that I had, where the steps are going down and then the buildings are sequentially getting taller as they come in. This one's kind of like the opposite, where it's like, I don't have any, so this is based on flat land, nothing to do with steps. We can do steps, I guess, but pretty much this one's just starting off with flat land, then real tall outer walls or outer buildings, which look like walls, like, but they're buildings and they serve purposes. And then inside it goes down, then down, then down, until the very middle you have the tallest building, Prototype Generation Tower, which will have a magnificent view. It's almost like look like a giant city scale, like on the scale of a city, but like it look like a giant stadium, where like it's sequentially going up and up and up as it goes out and out and out. And so from the very middle tower, it's like a watchtower. You can basically see everything in the city. So this is, yeah, rough sketch, general overview. So we have the outer buildings here. So this is gap here, outer buildings, gap, outer buildings, gap. So it's like, and then that progressively goes inside. So another 4, and then another 4, another 4, and then you have Prototype Generation Tower in the middle, and then all in the middle of the gaps. So these, we have roads, highways, parks, recreational areas. All right. And next up, we have the Autobahn drive-through, or the to-go highway. This one's kind of a unique idea. So there's that. There we go. Come on, stay up. There we go. Just gotta tilt it back a little bit. You can pause if you'd like to see that. All right. So Autobahn drive-through or to-go highway. Why do we have to make individual stops for so many different things? We must maximize efficiency of transportation infrastructure by designing innovative ergonomic concepts. Drop packages in the trunk or separate compartment designated for cargo drops. So basically, you're driving down the highway. You have what I showed you here. So this is going to be kind of like a board, or like just kind of a thing that goes over the highway, and then it has all your different restaurants and everything. So you order on your app, and you can see on your phone where the different stations are, the to-go highway stations. You can see where those are. You can place your order, and it'll tell you like how long it'll take. It'll tell you how soon you have to order before, because it's going to take a certain amount of time to make. And then so it's going to show you on the screen like you have to order it at least 5 minutes before. And so you're going to have a deadline. Like if you pass the deadline, you're not going to be able to order. Say if you're 5 miles away, or like say 5 minutes away, and it takes 10 minutes to make, like it's not going to even accept your order because it's not going to be done by the time you get there in the car, right? Say if you're 11 minutes away and it takes 10 minutes to make, it'll be good because you'll still have an extra minute to spare. And I think this will be a lot easier to coordinate if we have the self-driving vehicles and not everybody's driving at different speeds. So this will be a lot easier when we have a lot easier to implement once we have like fully autonomous vehicles all going at all going at speeds that are able to be predicted and calculated because they're all connected to the overall system of transportation monitoring and regulation and all that. All right, so lane one. So for example, so we have lanes going this way, lanes going that way. On lanes 1, 2, and 3 going this way, we have In-N-Out, Taco Bell, and Subway. Lanes 4, 5, and 6 going this way, we have McDonald's, Burger King, and Pizza Hut. We have a picture of what these things would look like. So essentially, they can be posted like restaurant, restaurant, restaurant here, but they can also be made a little bit longer so they can have restaurant, restaurant, restaurant there, or just be kind of spread out where you have one beam going this way, like that's at a certain width and length, and then we have another one maybe a mile away. So you have them kind of sporadically placed. Kind of cover a wider area that way too. All right, so we have one on top is ingredient storage. Inside is the food preparation chamber. And then down below, the takeout turrets, aka takeout turrets, or food and drink dispensers, aka takeout turrets. Then on this side, so when the car's coming this way, there's a little slanted screen too. It's a screen for the company name or logo. So that's where you see In-N-Out, Taco Bell, Subway, either the name or the logo. Then next we have some more highway, which is like the clearance zone between the two containers, or unless it's one with like 3 separate ones. So like depending on the business, you might have like Taco Bell that has 3 separate food chambers or food preparation compartments stacked right next to each other. So we have little clearance zones between there. Food and drink dispensers. Then we have projectors on the back to display digital images. So I said, unless there's a proper collection method for reusable resources, in other words, crates, plates, tools, devices, etc., it may be more sensible to utilize disposable and biodegradable materials and ingredients. This concept is meant to be applicable for all commercial goods, not just food and drink services. Consider that we may need to start off with non-fragile products to avoid breakage, and just basically have time to prove that the system works with some things. Consider that we may need to start off with non-fragile products to avoid breakage. Collaborate to go turret launch pressure correctly to avoid collateral damage. Yeah, so we don't want that thing shooting, blasting out like weapon. We don't want that thing to be a weapon, like shooting out things too quickly, just basically dropping it into the car, being able to calculate how fast the car is coming, how long it'll take to drop, basically do that math, like have that car pass by and just like drop it and like have a little bit of pressure so it drops a little bit faster so it can be timed properly, but not so fast where it breaks the product or damages the vehicle when it's being dropped in, or maybe even like doesn't damage like someone when it's being dropped in. And ideally the compartments will be placed somewhere else too. So like in the trunk or something like that. So, or in the front of the car, in the back of the car, somewhere where people aren't right where they're sitting, kind of like maybe behind them. So when the car's passing by, you got like 1, 2, 3, 4 people sitting there. You got the trunk here or a compartment there. And so they pass by, and then this thing shoots out. So even if it shoots, we don't want it in front because it could go like that and possibly miss and go like fall all over the front of the car. Can't see anything, can't and possibly damages the vehicle. So we want these 4 people going, and then it launches behind them so it doesn't affect them. Launches in the car, you got the timing right, so it goes in there. Or you have just a thing on top of the car, which probably seems less likely. It's not going to be as aesthetically pleasing, and it's also not going to be as aerodynamic if you have a big bulky thing on top of the car to collect it. Plus, after you get out of the car, then you have to find a way to get to it, or have like a whole entire different module or device connected to it that opens up from the top and then you have to feed through it. That seems like a lot more work. So I think just having 4 people up here, trunk separate, turret, take out turret, drops it into the trunk in the back. Drops it or slightly propels it into the trunk. All right. Felt like maybe I continued on this one somewhere, but all right. Next up, we have a beach recreational park. A bicycle ramp and or slippery slides that lead off over the water so people can jump into the ocean in all sorts of epic ways. Create a photo taking station. The camera is set up at the bottom and takes pictures when people flying past and sends it to the photo booth where they can be printed and collected. There's a man-made cliff people can use to jump or glide into the ocean, or you can even do several of these. There will be a photo booth, skate park, bike trails, walking trails, hiking trails, informative plaques and signs for plants, different scenery and stuff, museum, and photo spots, and several vantage points and vista points. All right, this one is infrastructure for a city, just kind of doing a grid, sort of a grid design with different shaped squares. The city and city or state organization. So essentially have the big square, or actually, okay, so hold on. Yeah, big square would be downtown, factories and warehouses, office buildings and government buildings. The medium-sized squares would be mid-city, shopping and food and supplies. The smallest little squares will be suburbs and housing. In between each of the squares in the gap areas will be free space for parks and recreation. And then moving diagonally between the squares and vertically and horizontally between the squares. So you got a diagonal grid and a vertical or horizontal grid. Those are going to be the roads and highways and intercity roads. And we have, so that's like on a city scale. So you can do that same thing on a house and apartment scale, building in neighborhoods. And nothing, class 3. So view from above, you have the big central city building, then so in each corner, and then each side, we have middle buildings. So we have 8 of those, and 2, 3, 4. Then between those middle buildings, outside of the central building, we have a bunch of smaller buildings, which would be this suburbs or other units. So for the apartment version, these would basically just be different size apartments. For the city version, these would be different parts of the city designated for certain different activities. We have checkerboard infrastructure. Build cities in checker patterns, in other words, in a 9 square box where the top row from left to right is 1, 2, 3. The middle row from left to right is 4, 5, 6. And the bottom row from left to right is 7, 8, 9. Boxes 1, 3, 5, 7, and 9 are urban areas, while boxes 2, 4, 6, and 8 are rural areas. The larger the city is, the more rows and columns of alternating urban and rural areas they will have. All right, it's kind of cool. Kind of an interesting look. Crater City. What is the biggest hole we can possibly dig? How big of a hole can we dig? How deep can we dig, theoretically, legally, and ethically? How wide can we dig? I just want to dig a giant hole and keep on digging. Scientists are like, dude, you guys got to stop digging. We're almost at the center of the earth. And then like you're out in space and the whole entire earth just looks like that because we dug a I'm just kidding. Oh, that'd be funny. It looked like Death Star where it goes like that and you just see a giant hole like where it looks like the hollow part, but it looks like the Death Star because we just built a giant hole. But yeah, we dug that. We went to the beach one day and we just kept on digging. Next, the dodecahedron star tower. Or we have other ones called polyhedron towers. So these kind of look like that, just oddly shaped. I wanted like 20-sided and multiple sided, cool looking towers. Then I have dynamo towers. This one's an interesting idea, trying to conserve some energy. So dynamo towers, we have so each moving room. So okay, it looks like this. So I don't know if you can see that. So dynamo towers. This one's a little trickier to explain. So you see the arrows, and each of the dots is basically a room, and the arrows are what direction those rooms are moving. And so those rooms are basically moving all around the building at all times. And the pyramid one is a little bit more horizontal. And then I have other ones that go up, down, up, down, up, down. On their way down, essentially, they're collecting friction. So they use power to go up, but then collect energy and use the braking systems and collects friction to generate energy. The room situated at the peak or the highest point of the building or tower be in the middle. So there's one option where it spirals down, another one where it's a pyramid and it goes in different ways, either down the side angles or around the sides. Then there's a cylindrical type that goes up and down along the outside of the building. Each moving room takes 1 full month to complete 1 full cycle. Each moving room will have the opportunity to be at the very top at least 1 day per month. We have other versions that are a spherical design, so the rooms go around that way and then back around this way. Rooms move slow, about 1 mile per hour or less, to avoid damage to items or injury to people. How fast, I have a question here to research, how fast does the stratosphere in Las Vegas rotate? Match this speed for these designs, or match a similar speed. Axis of rotation on the spherical design shows it just spinning that way, clockwise. Rooms shifting toward the South Pole. So basically you see all the rooms, so imagine like the sphere, the pyramid, and you have all the rooms of the spiral, and then you have all the rooms all at once, like shifting in the same direction. Then you have rooms so you have some rooms on this side. So these are going down, these are going up, these are going down, these are going up, these are going down, these are going up. And then so you have them kind of like twisting like that. So it looks kind of like a fluidly moving thing from the outside. I think it'd be pretty cool. Axis of rotation, Helios Interstellar Armada. Ooh, okay, so this would be one maybe out in space. So I also even have an extra design that we can build out in space that would look similar. So you have a giant space station with like rooms going that way, other rooms going this way, and then even possibly even rings on the outside, but giant space station, and you kind of fly up to it and you just see everything moving, like the whole thing kind of looks like it's moving. Be super cool. Trip to the top is about, this is an arbitrary number here, about 1 day or 100 meters. Trip to the bottom. Oh, so you starting off on day 1, you're at the top, so it's about 100 meters high. Oh, I see. Okay, so you're going down. Imagine going down, 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 down. You're at the bottom. Then you go up the middle elevator. So you go up the elevator. That trip takes 1 day. So the whole entire trip from the bottom of the lobby to the top of the tower, that is 1 day. So you have 1 full day where you're in the middle and looking at stuff going on inside the building and stuff like that. And then the trip from the top back to the bottom, it's like 2,900 meters, 29 days. Back down to the bottom. Idea, side view, room raised through the center of the structure. So all the rooms going down on the pyramid at least. See that screenshot if you need to. All right. So all the rooms on the outside of the building are going down, 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 and then it gets to the bottom. Then it goes towards the middle of the building, and then goes straight up. Same thing with a cone type version, goes around like that, then it goes to the middle, comes back up. Top view. So room raised to the center of the structure. There, the top view shows the room uses gravity and braking mechanisms for a controlled descent, collect energy during descent by collecting heat energy generated by friction, then use this energy to power the lift that elevates the rooms. So yeah, basically you're going to have 29, I'm just throwing an arbitrary number again, different number of rooms later on, but say for example 29 rooms. 29 of those rooms are going to be coming down all at once. One of those rooms is going to be going up. So I'm thinking all the power from those 29 rooms coming down be enough to get that one room up. But then again, we're going to have to be doing this 30 different times. So I'm trying to think of the math there. So you got 29 rooms coming down, one comes up, then that one comes down with 28 others while another one's starting to come up. Are we then producing more energy than what we're exerting? No, okay. Yeah, no. It is going to even out, and then there's also going to be it's no way it's a perpetual energy motion machine sort of deal, because you're going to have one going up, that one goes up, 29 others are coming down, but that one is going to take 29 days to come down, and then 20 or 30 days to come down. 29 others are going to come up, so you need to power 29 coming up with 30 coming down. So it's going to even out eventually anyway. So you got, I'm trying to see if I can explain this right. I feel like I'm not explaining this correctly. But you have the cone, you have one in the middle, that one goes up. That takes like one energy, 1 unit of energy, imagine. And then we have 30 or 29 other units of energy produced. But that 1 unit of energy is going to go all the way down, all the way down, all the way down. And then another one, so the next one after that one that goes up, that one starts going down, the next one goes up, that's going to take a unit of energy. Then that one starts going down. And the next one comes up, that's going to take a unit of energy, and the other one goes down. That first one, go back to the first one, that 1 unit of energy, that's going to keep on coming down, 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 and down until it eventually gets back to the point where it needs that amount of energy to come back up. So yeah, it'll balance out. I tried so hard to explain that correctly. This is why we just asked Gemini. Gemini can probably explain it better. All right, the room uses gravity. Okay. So I have an example here for 100 to 10,000 rooms. Power the lift or elevate the room uses so many watt hours, so much percent. Power generated via friction is so many watt hours, so much percent. I'm trying to tell what that says there. All right, so the energy cost is hyphen negative. It's gonna be so many watts, so much money. And then energy gain, how much watts are we gaining from breaking from the friction or heat energy collected, and then how much energy is gained back in money. So yeah, so I need to do some math there to see exactly how much energy in total we'd be losing. But I'd imagine by setting it up this way, we wouldn't be losing as much, and it would be closer to a balance in energy gained and energy lost. There's going to be more energy lost due to heat energy. Was it the second law of thermodynamics? But at the same time, it's still something that I think we can use to conserve energy better. So we don't have to use as much energy by, we can regain a lot of energy by having it set up like this, possibly. Again, just an idea. I need to do more math and figure that out, talk to more engineers. See what we can do with that. All right. I'm gonna get through maybe a few more ideas, but I gotta go do something else. So yeah, I knew Acroscape was gonna take a minute. I got a bunch of ideas for Acroscape. All right, so the Ecumenopolis, I have a subterranean version of the Ecumenopolis, or at least that's what I started doing here, and then I think I went into something else. So this is, yeah, something else. So we got drone net tracking using sonar and scent. drone optics. Scan a bubble of area that overlaps and communicates, scanning with other drones to point a map of scanning area, or to paint a map of scanning area. Some towers serve as zip line or transport zip hubs placed throughout the city. Oh, so I think this one was like for police, like a police station, and then you have like wires or cables that send the trams to wherever they need to go. Or basically maybe it spins and then you have drones on the end, and it'll just kind of slingshot them to wherever they need to go. So the drones will be on the ends of the string like that, spinning. And then whenever they reach a certain point, like when they need to go this direction, they'll release from the string at a certain time, be launched in that direction. Yeah, so started off with subterranean to Cumenopolis. New idea now. Drone tracking, that's different. Probably going to be a Neotech. Subs, UUV, unmanned undersea vehicle, different note. All right, so I have a tower here with a ring around it. Kind of looks like the stratosphere where it goes up like a needle and then goes around, has a big building on top, then antenna on top. Then we have another ring over here with strings and cables, and then little cable cars that can be attached to them and go attached to other buildings. Zip lines between buildings with zip lines between buildings with peaks, 3 to 4 floors of difference or more than 200 feet apart. So basically, there can't be more than like a certain level of distance. So like this, like if you're going from this building to this building, you can only go like 3 to 4 floors up. You can't take the cable and go like 10 floors up. So I mean, you'd be going too fast. Well, I mean, we have elevators where they go straight down. I guess you could just slow it down, but for safety, I think just having it more horizontal would prevent it from potentially slipping and crashing into something. And also the distance too. You can't have it go too far, otherwise it'll just slack like that. And so, I mean, ideally, we would have them taut. The cables will be TAUGHT, taut enough to suspend the car horizontally without it sinking down like that. But they'll need to be close enough where it would safely be transported from one building to another, and not too tall. So the lower buildings connected to the highest neighboring floor. Okay, so lower buildings, we can have bridges and other cables connected to. So the highest floor of the lowest building is connected to another floor on a higher building. All right. And then air police station. So I have a bunch of cones set up like all throughout the city. So those are all buildings, and then those are imagine a ring of cones. So cone here, cone here, cone, 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 ring of cones. Each cone is connected by a cable, and then each cone is connected to each cone is connected to the adjacent cone by a cable, and then also each cone is connected to the central hub station. That the central hub station is suspended completely above the ground by the cables connected to the outside cones. That central station, I'm throwing here as a police station, but we could have like the central government office, we could have a watchtower, we could have other things too. But that's kind of connected as a central hub, and that can relay information, cable cars, people to the other cone buildings on the outside. So you go to and from it, but that's suspended over the city while the cones are surrounding it. And again, it would have to be a practical length too, so we'd have to figure out exactly how far apart these cone buildings can be, how long the cables need to be, and then what distance the all the cones are, what the circumference of the overall circle is if you were to connect it, and then how long those cables would need to be, how far up off the ground that central hub would need to be, how close it would need to be to the outside, basically what the radius and diameter of the whole entire structure would be together collectively. And we have options for fast deployment. So you have, it's like a side view. So you have cones out here and they're still going around this way, but we're taking these two cones, the cable's going into the central hub, and then the central hub, we have like drones and stuff like that flowing from that all in and out in all directions. Where the zone of, or the perimeter that they sweep or that they can cover is like kind of like a bubble within that, surrounding that central hub, but also encapsulates all the other cone buildings. Oh man. All right. 50 minutes. Got 10 more minutes. Try to limit at an hour. Not gonna do like hours and hours of video, but we're gonna get through this eventually, and gotta get through these notes and just get it out into the world, man. Because unless I'm doing something with it, I need somebody doing something with it. I got ideas that I feel like can benefit the world, make it a better place, make it more convenient, make it more fun, make it safer. All that, all at once. All right, Cumenopolis on the surface, pyramid stacking. So here, this is what I'm looking at. You can pause, take a photo if you need to. So that's what I'm looking at. Okay. Pyramid stacking. Place pyramids on the surface of the planet in rows that match the number of columns. In other words, 2 by 2, 4 by 4, 10 by 10, 100 by 100, 1,000 by 1,000, etc. See figure below. We have a side view. We got, so it looks like triangles, but they're pyramids. So side 2D view, it's gonna look like that. Top view, facing down, you're gonna see the top of all the pyramids. So you're gonna see like one pyramid here, like the point over here, another pyramid point. So looking down on the pyramids is a 4 by 4 pyramid grid. On the first layer of the pyramids, place upside down pyramids interlocking with the first layer by being precisely placed directly in the center where 4 pyramids come together. So yeah, pyramid, 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 pyramid. Another pyramid is going to go right in between those 4 pyramids, like right where those the cross of those 4 pyramids, where those 4 pyramids meet, that's where another pyramid goes, inverted. And then we keep on stacking sequentially off of that. Layer 1, upright. Layer 2, inverted. Layer 3, back upright. Layer 4, inverted. It's got a diagram here, looks good. Placed directly atop each inverted pyramid will be an upright pyramid. The process of spreading out horizontally, then stacking pyramids vertically will continue until there is no more room to build anymore. Right. We have an idea for Rhomboid Towers Shopping Plaza. Pyramids, domes, and arches are considered one of the most reliable and structurally sound designs. If this is true, would it be possible to build a pyramid that starts off at a certain height and as renovations and expansion commences, works in phases, not at once, working in phases, not all at once? The pyramid starts as an enormous trapezoid-shaped mesa. Exact dimensions can possibly exceed several acres of land space. The pyramid shape will not truly form completely until the final phases of construction are completed and the entire structure is deemed to be fully complete. During phase 1, construction will produce a colossal mall-like hub for shopping, trade, and commerce. Underground or at ground level is where the warehouses, factories, distribution centers, research facilities, etc. are located. As the pyramid grows, more and more sources of profit and advertisement will fill the new spaces being built. During phase 2, corporate offices are added. During phase 3, living spaces such as apartments, common or luxury, depending on the location. Following every expansion, prices are adjusted. For example, once phase 2 begins, spaces available for rent either go down as the prices of new properties are initially set higher than older properties, or prices will go. What? For example, once spaces available for rent will either go down as prices of new properties are initially set higher than older properties, or prices will go down and prices of new properties will match the old price of the old properties. What? So spaces available for rent will either go down. So prices for spaces available to rent will go down as the prices for new properties are initially set higher than old properties, or will stay the same. Or, yeah, so the old properties, those will be, the price of those will drop as new properties are built, or those properties will be built higher because there's more opportunity and that whole entire space is more valuable. Price properties. Residents can be grandfathered in and locked into a certain price if they are already signed into a contract preceding the deadline marking the commencement of a new phase of construction. Build it and they'll come. All right. We got 55 minutes. All right. So we have an idea here, more of a note to build an underground ecumenopolis design, a surface ecumenopolis, atmospheric or sky ecumenopolis, and orbital ecumenopolis. All right. Ergonomics. Try to discover and develop the most ergonomic designs possible for restaurants, schools, offices, factories, etc. They did an experiment similar to this in the Founder movie with what was his name? Not Kevin Costner. What's his name? The guy that plays Vulture in Spider-Man: Homecoming. He plays the Birdman and something else. I always forget his name. Jeez. That dude though. Like whoever knows what I'm talking about, you know what I'm talking about. Kevin something? I don't know, man. All right. Well, anyway, he basically in that movie, in the Founder movie, him and the other guy, they're on like a basketball court or a tennis court, and they're drawing on chalk how to make the most ergonomic McDonald's, like how to position their workers so that way they can move fastest and get orders out. So when they get their order, they bring the order, and then they make the food, make the fries and everything like that in exactly the right places so it can be expedited and brought out as soon as possible. And so they did that. I need to try to do that, or I'm sure other people are working on that. I just need to kind of get in touch with their research and use that towards building spaces that I have and building spaces that I use to save money and increase productivity. All right, I have an AI assist ergonomic office. So we have 4 different tables, and then when one table is chosen, so you have 4 different desks almost. So you have one kind of front desk, it's like a real thin table, just enough to maybe write on a piece of paper or something. Then you have 4 screens over here, and then you have one that can come up this way, so you can kind of pull them up. So you have this big screen like that, and then this one gets pulled up bigger, and big main screen. So maybe a big main screen here that's kind of glass and you can see through, but you also have another screen back here that shows you smaller screens. And then when you choose one of these screens, it pops up to the main screen, so you can kind of send it back or bring others forward. You have one zooming up this way, all zoomed out again, and then zooming up this way from this side. So you can just kind of choose different screens, and I think it'd be kind of cool just setting it up a little bit differently. Flotilla barges. Considering the fact that Earth's crust essentially floats on a sea of molten iron ore and lava, upscale barges to resemble Earth's crust floating to the size of entire continents and later even larger. Barges can be several layers thick to allow for the seamless integration of multiple operations being conducted simultaneously, ranging from several millimeters or nanometers to several meters or terameters. So basically, I think this goes hand in hand with yeah. Here we go. We're continuing. So the idea is continue. It's basically we could do this on a continental scale, like a planetary scale. Imagine planets are completely made out of lava or something like that, with continents or something like that. But that's on a huge cosmic scale, but we could also do it on a more practical, reasonable scale where we take barges, like kind of like yachts, like yacht sized barges, but big flat things, circles, squares, rectangles, whatever. And we stick them out to the ocean, let them float. And then we kind of use some space in the ocean, connect cables and connect roads and stuff like that. Just have a barge and then connect that with a road to another barge. And we're kind of just floating, and we can have kind of cables, maybe not roads, because like with waves and everything like that could compromise the structural integrity of it. I think maybe more cables and have like a real fast maglev system connected to it. All right, so continuing the flotilla barges. So I kind of have it where it shows connecting different continents. Oh my God, so much glare. Okay, there we go. So it's connecting different continents. That's what I'm trying to point. Where am I? Here, here, and here are just examples. So you see how they're connected to each other via highway, rail, maglev, cable, whatever. And then you have the hubs positioned at each area, and then you can even have smaller hubs, like one's like a big city size one, one's like a little town size one. Like you just have them spread out all across the ocean. People wouldn't even live there. You have more space to live, and we have land actually freed up. So people are living on the ocean on those barges and stuff like that, and have resources transported to them. We have more land freed up for farming and agriculture and other things. And then, I mean, because people nowadays they have everything shipped to them anyway. Like nobody's like hardly anybody's getting everything they have locally. Like they're getting their Wi-Fi. I mean, obviously Wi-Fi, but they're getting their food. They're getting their produce. They're getting their milk, eggs, avocados from different countries, different states. Like everything's almost like I wonder what percentage of what we consume, the average person on average, how much of what we consume is actually within like a 10-mile radius versus how much of what we consume is beyond 10 miles or beyond 100 miles even. I think that this idea would work simply based off the fact that most people have things imported anyway, and that way we can free up land space and import things via drones, trucks, boats, trains, planes, trains, automobiles, whatever it might be, whatever transportation method we might use, and then transport that to wherever they might be in the ocean once we set up interconnected vessels. And then we could also have those, especially if you're on the ocean, you're probably going to be moving around a little bit. We could have those coordinates set up, and then even have devices on the boats where they remain stationary, or possibly even anchor them down. If they're on parts of the ocean where it's really, really deep underneath them, anchoring isn't really as reasonable of a solution, we can use different devices like GPS devices that kind of power the ship, and propellers on each side that'll move it, or thrusters, propellers, whatever you might use, fans, intakes, anything you might use to basically just move it and reposition it so that way it's still in the same exact coordinates on Earth as before, relative to other things. All right, so let's read this. Barges and artificial land masses connect to create an intercontinental trade and commerce apparatus, which is faster than boats, but needs to be but needs equal or more energy to be efficient and cost effective to produce and maintain. Well, I mean, the barges are stationary themselves; those aren't moving fast, but you can move along fast along the barges on the rails and other infrastructure we might build. That could be an opportunity to build some really cool new infrastructure. Barges and artificial islands can be used as additional land space required for farming, research, manufacturing, living, shopping, consumption, etc. Tracks connecting the barges can be used to transport cargo via various transportation methods, either rail, road, etc. All right. I'm going to take a pause right here. We're at about an hour, and I'm not even halfway through my binder notes for Aquascape. So we're going to keep on going hard when we get back. But I got to pack, and I'll catch you on the next one. Thanks for watching, and hope I had some decent ideas and maybe got some people thinking a little bit. like I said, like I've said before, man, I'm gonna say many times. Some of them are crap, some of them are great, some of them are just need a little bit of work. I think even the ones that need work, I can bring up to being pretty decent, but I'm trying to look for all the really good ones and at least just get ideas out there. So maybe if not getting to it quite yet, maybe somebody else can start working on it. So that way the world can at least have access to different ideas I have. And so you might be listening, you might be watching this video, and 99 of my ideas, you think, oh, that sucks. But one of them might be able to use. So that's how I kind of listen to other people, and I'll hear them out regardless. There might be one thing that they say that might be good, and I know like 99-to-1 ratio is not what it is here. Like it's definitely, I'd say like 1 out of 5. 1 out of 5 to 1 out of 10 are pretty good, which is a really damn good ratio. So we'll see how many of these we can use, how many that others can use, and if anybody has any comments or wants to collaborate, by all means, I am all ears and fully open to it. So cool.